Have you ever stopped to think about how our sun would be seen from a planet orbiting the star closest to Earth? The answer lies in one of the most fascinating systems in the cosmic neighborhood, Alpha Centauri. Those who live in the southern hemisphere of our planet have the privilege of contemplating this system clearly in the night sky, but what many do not know is that it harbors the stars closest to us, after the Sun itself. This stellar system is located just over 4 light-years from Earth, a relatively short distance in galactic terms. It shares with us this same corner of the Milky Way, and because it is so close, the sky of an imaginary planet there would have a quite familiar appearance. However, there would be something absolutely unique and exciting in the firmament, the discrete but noticeable presence of our own sun shining in the distance, like a simple star among thousands. Although our sky seems crammed with twinkling points, what we see represents only a minuscule fraction of the true stellar population of the galaxy. Even under the most ideal conditions, far from light pollution and with a completely clean atmosphere, we can distinguish at most about 8,000 stars with the naked eye. It may seem like a lot, but it is a drop in the ocean of a cosmic ocean that harbors hundreds of billions of stars. This reduced number is due to the enormous distance between us and most of the visible stars are no more than 3,000 light-years away, with few exceptions that exceed this mark. Further than that, only with advanced instruments such as powerful telescopes is it possible to detect the faint light of these stars almost invisible to the human eye. But the visibility of a star in the sky does not depend only on distance. The intensity with which it shines is also linked to its own luminous energy, that is, how much it radiates, and its composition. There are extremely close stars, like the discrete Proxima Centauri, which, even being the closest star to the Sun, cannot be seen without the aid of equipment because it simply emits too little light. On the other hand, there are stellar colossi thousands of light-years away, like those that form the famous constellation of Orion, that shine so much that they seem to be much closer than they really are. These giant stars of Orion are supergiants with an absurd emission power. They pour into space a colossal amount of luminous energy, which allows them to shine with enough force to cross immense distances. In contrast, Proxima Centauri is a small star, of the red dwarf type, that produces about 20,000 times less light than our Sun. Enough so that, even being so close, it remains invisible to the human eye. Now, imagine that we could travel to this neighboring stellar system. Even being the closest to ours, Alpha Centauri is about 4.2 light-years away. It may not seem like much on paper, but this measure represents something around 40 trillion kilometers. To get an idea of what this means, it is approximately 270,000 times the distance between the Earth and the Sun. Or, for another level of comparison, it is 100 million times the distance between the Earth and the Moon. This without mentioning that it is equivalent to 1 trillion laps around our planet. Alpha Centauri is not a solitary star. In truth, it is a triple system, formed by 3 stars that gravitationally influence each other. 2 of them orbit around a common center of mass, while the third, Proxima Centauri, revolves around the 2 main ones like a distant satellite. This complex configuration makes the system a fascinating natural laboratory for astronomers. The star baptized as Alpha Centauri A is the most luminous and massive of the trio. It is responsible for a good part of the visible brightness that we can detect from Earth. Its mass is about 10% greater than that of the Sun, and its diameter is also impressive, with up to 22% more in relation to our star king. At its side is Alpha Centauri B, its slightly smaller companion, separated by a distance similar to that which exists between the Sun and Uranus, which means about 3 billion kilometers. These 2 stars perform an intricate gravitational dance, completing an orbit around each other over a period of up to 80 years. The third member of the system, the small and dim Proxima Centauri, is classified as a red dwarf with such weak brightness that, even being part of the closest system to Earth, it is not able to stand out in our sky. Its light emission is thousands of times less than that of the Sun, which makes it invisible to the naked eye, despite its astronomical importance. In contrast, Alpha Centauri A and B can be seen from the southern hemisphere with relative ease, and on clear nights, their luminosity can compete with some of the most prominent stars in the night sky. To think that these distant points of light are, in fact, the suns of another neighboring planetary system, invites us to reflect on our place in the universe and the possibilities that the cosmos still holds. And if you enjoyed traveling through this little piece of the galaxy, imagine what else we have to explore. There is much more waiting for you in the next episodes. Like, share with those who also love the universe, and tell me in the comments, what else would you like to see through the eyes of another planet? Have you ever wondered how our sun would appear if we were observing the sky from Alpha Centauri? Would it be possible to see it clearly even at such a gigantic distance? Would the light emitted by our star manage to cross the interstellar vacuum and still stand out among so many other luminous points in the firmament? The surprising answer is that yes, the sun would be one of the most radiant stars in the sky of Alpha Centauri, figuring among the most prominent celestial bodies of that system. Although there are still no confirmations of planets orbiting the main pair of stars of Alpha Centauri, we know that Proxima Centauri, the third star of the system, already has 3 confirmed planets around it. So, out of pure scientific curiosity, let's imagine a hypothetical observer on one of these distant worlds, contemplating the night sky with attentive eyes and a mind full of question. Let's imagine that this person, perhaps a curious alien scientist, is on the surface of one of these planets. From there, Proxima Centauri is a little closer to our Sun than the central stellar pair, which could offer a slight advantage for astronomical observation. But even with that, the doubt arises. Would the light of our Sun manage to stand out in the sky of a system illuminated by 2 stars similar to it? Would our star be as striking there as Alpha Centauri is for us? To understand this more clearly, we need to explore some fundamental concepts of astronomy, starting with the scale of stellar brightness called apparent magnitude. This is a system used to classify how bright a celestial body appears to an observer on Earth, and differs from absolute magnitude, which measures the intrinsic brightness of the star at a standard distance of 32.6 light-years. In this case, we will focus on apparent magnitude, as it is what defines how the eyes, whether human or alien, perceive the celestial bodies in the sky. Alpha Centauri, which is about 4 light-years from us, possesses an apparent magnitude of 0.2. That value is quite high in terms of brightness, and it is important to remember that the smaller the number on the scale, the more luminous the star is for the observer. But how would we measure the brightness of the sun if we observed it from there? For that, we apply a physical law known as the inverse square law, which establishes that the intensity of light decreases in proportion to the square of the distance at which it propagates. This means that, if you double the distance from the light source, the intensity of the light will be reduced to only 1/4 of the original value. Thus, the light of the sun weakens as it travels through space, but this does not mean that it disappears completely. When seen from Earth, the sun is extremely bright, with an apparent magnitude of approximately -27. A value that places it as the brightest object in the sky. Even at the limits of the solar system, in the surroundings of Pluto, it still emits enough light to illuminate the sky as if we were living a constant late afternoon. However, when we reach the distance of Alpha Centauri, this luminosity decreases drastically, and the sun would become just another star among many. Still, it would not go unnoticed. An attentive observer would perceive the sun as a twinkling point in the sky, with a magnitude close to 0.4. To have a comparative idea, this brightness would be slightly superior to that of Betelgeuse, one of the most well-known stars in the constellation of Orion, which possesses a magnitude of about 0.45. 4 light-years may seem like an almost insurmountable vastness, and it is indeed a colossal distance. However, it is still close enough so that sunlight can be clearly detected, even if its presence is limited to a discrete bright point. Other stars visible from Earth, like Sirius, would continue to be more radiant than the Sun in that new sky, due to their greater intrinsic luminosity and relative proximity. The interesting thing is that the stellar panorama seen from Alpha Centauri would not change as much as one imagined. Many constellations that we know would remain recognizable, with small alterations in relative position. Sirius, for example, would still be visible near Betelgeuse, but the slight change of perspective would cause their positions to shift a little. Our Sun, on the other hand, would appear in the sky of the constellation Cassiopeia, and, curiously, would be the brightest point in that celestial figure. Now, imagine that the inhabitants of this system have developed telescopes similar to ours. If they pointed their lenses towards Earth, they would not be able to directly see the planets of our solar system. However, perhaps they would be capable of identifying Jupiter, thanks to its gravitational influence on the movement of the Sun, a trick that we also use to discover exoplanets around other stars. So yes, it is perfectly plausible that the Sun could be observed from Alpha Centauri, although it would not be the most resplendent in the sky of that system. It would shine with dignity, but without eclipsing the others. And it is fascinating to think that perhaps, somewhere over there exist beings contemplating the night sky, without even imagining that, just 4 light-years away, there is a blue planet, full of life, looking back with the same curiosity. If you enjoyed this imaginative journey through space and want to continue exploring the mysteries of the cosmos, don't forget to leave your like and subscribe to the channel. This way, you won't miss any of our next trips between the stars.